All right, well, we can get started. Okay, so yeah, my name is Kouremetis. I'm one of the lead devs for Caldera, as well as a principal investigator for an internal research project at MITRE called DITIS. Today, we wanted to do a tutorial on Caldera, MITRE's adversary emulation platform. And the reason was we wanted to show the capabilities of it, but then essentially show how it is. We use it as a kind of foundational platform for testing out deceptions against automated planners within the cybersecurity domain. So to be able to test an automated planner running a offensive cyber operation, and test out deceptions against that operation and see the effects of the deceptions on the planner. And so much of the tutorial today will be an intro to Caldera as the deception piece and the experimentation piece is just kind of a light plugin that we have built on top of Caldera. And so we use most of the current and existing functionality of Caldera. So that's what we'll go through today. We have a lot of different components to go over. If anyone has questions, I would prefer to, kind of ask me right on the spot while we're going through something. Yeah, because we do have a good amount of time today, and so I think we padded enough that we can go down tangents or dive into something if anyone has any questions. But with that, I'll go ahead and get started. What I first wanted to do was just kind of show the main web pages of Caldera that you can always reference for resources and instruction. So if you have to remember one URL, it's just this caldera.mitre.org. This is kind of a landing page that can get you to everything else related to Caldera. So one of the first big links is just to our GitHub. And so if we go to our GitHub here, this is our primary Caldera GitHub, where the core of the platform is. We'll get into this later, but Caldera also consists of many plugins built on top of kind of the core architecture. Those plugins are also Git repos, and so they're also open source, and we have access to them. But we will walk through this today, but there are the installation instructions and how to deploy from on the GitHub. And then another really important link is our documentation. Our documentation is pretty good and pretty extensive. So you see we have a read the docs instance here. Again, we'll go over a lot of this today with the tutorial, but there's lots of advanced concepts that and just other stuff that we won't go over today. And so there is a lot of good material here in the read the docs. If you're ever having questions beyond the docs or can't find an answer, we do have our own user Slack channel that you are welcome to join. And so this is essentially a channel dedicated to Caldera, and all of the Caldera dev team is on it. And so we are active and we always answer questions. So it's just a direct way if you want to interface with us and ask any questions. Let me go back. Yeah, I think that's it for our main page. We also will be putting up some further blog posts on intro articles on Medium, but those links will be found here as well, and possibly on our GitHub. But with that, let's go ahead and start getting into installing Caldera from GitHub. And so I've kind of skipped going over all what Caldera does because we're going to do it ourselves, and so I think it'll be duplicative. So bear with me here while we install it before we know exactly what it is and what's going on. General architecture of Caldera is that it is a server plus agents or implants that are on a target host. And so it's a command and control server with a full user interface. that we can access and run operations. So what we're going to do really is pull the core code down and boot that command and control server, which gives us a nice UI, and we can go from there. So I'm actually going to switch my screen here. Actually, I don't need to do that. So what I did, which I don't need to redo, because it's just one command, is to clone Caldera. We essentially want to run this command right here, this git clone with the recursive. The recursive option will grab all of our plugins as well that are listed right here. Kind of a clarification on terminology. So plugins, right, are optional, and so they don't necessarily have to be booted or downloaded and then booted along with Caldera. However, a lot of our plugins have become really essential. And so for one that we'll look at today, Stockpile is essentially a repository of offensive abilities and adversaries. And so while you can disable this and not load it in, we have found that 99.9% of users and us, essentially expect Stockpile to be there, and that plugin is really integral to running Caldera. So that's why we do the recursive. The recursive will get all of these plugins that really have become essentially pretty streamlined and primary functionality, as well as the core. You can also specify the tag or the version if you want, by just adding -- branch and then doing the version. I will do a plug. We just released version 4. So our newest version was literally yesterday. And so if you do pull Caldera down, I would recommend pulling down our newest release. But essentially, all I did was do a git clone and then a pip install of our requirements. Caldera primarily uses all Python dependencies, and then through that also some other language dependencies like Go, but it's mostly pip modules, and so we expect Python to be available on the system that will be running the server. The architect or the server itself is run through Python async IO package. So essentially, you're running a full server in Python, and we don't really go too much out of the Python space for 99% of our server functionality. So I'm going to go ahead and switch over to a different window now, to my terminal here. And so you can see, essentially, I've git cloned Caldera down, and so I'm just in the home or the root directory of Caldera. I also did my pip install already, so I have all my requirements. I am on a Python virtual environment. I do recommend that you create a virtual environment, a Python virtual environment for running Caldera, as we do have a lot of dependencies, so it's nice just to keep that all in a virtual environment. But given that we have a requirements, the only next thing to do is to start our server, which is a very simple command of python server.py. You can see we have a few options when starting the server. Not that many actually, but we can increase, our logging verbosity. We can pick an environment, and then the two that I'm going to use today are the fresh flag and the insecure flag. The fresh flag essentially blows away the database that Caldera is using when it runs. And so when Caldera runs, it creates, all these operations data and objects from your operations. And so if you want to start up Caldera fresh, you supply the fresh flag, and essentially it just blows that away before booting it. And then our insecure flag, which is a utility flag if we kind of want to use Caldera in an unsecure manner or really just default configuration. So we use this flag for doing demos like this and just local testing. Essentially, which we'll see in a second, it just uses default configuration, and by default, the passwords are basic common passwords, and so that's why we call it insecure. I'm going to go ahead and boot our server. So now you can see I started this in the terminal window. You can start Caldera in a detached mode. You just have to specify that in the config file, which I'll show in a second. But there is a lot of output here on the terminal. It's really because of all the dependencies and all the plugins that we're loading and working on. You can see that there are errors coming up. These errors usually always relate to plugins or some sort of loading. And so, for instance, I didn't install the dependencies for a plugin called Human, which we'll go over later. I did this purposely, but it's just showing you that it's not loading. But if you look at the final line here, we have all systems ready. Essentially, if you get to that point, that means Caldera server is ready to be accessed to the browser. And so you can ignore kind of the verbosity of logs that we have here. This is mostly for us and debug. And a lot of our users boot Caldera in the detached kind of daemon mode, and so they don't see this anyways. But anyways, don't be alarmed if you see the errors, as long as you see this final all systems ready login message at the end here. So now I'm going to go ahead and switch back to my browser window. And I'm going to go ahead and navigate to our Caldera instance. So as you saw, I booted it locally. This is running on my Mac machine. By default, Caldera will be served up on localhost at port 8888. So I'm going to have that bookmarked. But you can see here, we hit it, and here's our login screen of Caldera. Since I booted it in secure mode, our username and password are just admin, so it's admin. And now you can see that we have got into basically the landing dashboard of Caldera. I'm going to take a brief pause if there's any questions with just getting Caldera booted there. Cool, okay, I don't see anything. So continuing on, one of the first things you'll notice is kind of highlighted links to any type of info that happened on startup, as well as if you need help getting started. So we have a one startup message here. Essentially, this is just an info on one of the dependencies wasn't exactly as desired. This one we know is not a big deal. Usually our startup messages will not be errors, or if there is an error, the server won't boot. So these are more of like info and warnings on possible dependencies and loading issues. We also have the get starting guide here as well. So if you hit that, you go right back to the read the docs that we have. So that link is kind of built in. Let me see, what else do I want to go over before going into the hamburger menu here? Oh yes, basic configuration. So you see, we have Caldera up and running, and we ran it with default. Essentially, if we want to change any of the configuration for booting Caldera, let me change my screen again. Can everyone see a VS Code window now?
Yes.
Cool, thank you. So I'm actually down in my Caldera directory under the subdirectory of conf for configuration, and then default YAML. And so here we have all of the configuration for booting Caldera. You can see there's quite a lot of options you can change just through this YAML. But for instance, what I mentioned before with changing the passwords, if you do want to change those passwords, they are down here. So we logged in as the red user, and so our password was admin. If we want to change that, we would just change it in this configuration file here. Another key one is what port do we want to serve up the web server on, so you can just change that here. And then also, if you want to disable or enable plugins, you add them to this list right here. And so that'll teach, or that'll tell Caldera to load the plugin or not. And so it'll look in the plugins directory and try to find it. We have a ton of other configuration here. I won't go over too much of it. It's pretty self-explanatory once you understand some of the Caldera terminology. Yeah, so the majority or key configuration details are here. And you can obviously copy it and create variations of the configuration and then just specify it, boot time if you want to save different configurations of Caldera. All right, I'm going to go ahead and switch back to our server. Okay. So right, the first thing you kind of realize or notice on Caldera server is we have this giant hamburger menu on the left side here with all of these components and kind of sub-menus to look at. The order of this is kind of, top to bottom is prioritized. So the more likely you're going to use a feature or capability, the higher it is. So campaigns are really the majority of where we'll spend our time. And so I'll get into these components here in a second. But we also list the plugins that are loaded. Every plugin can have a landing page or a UI associated with it. So some plugins just kind of have, like Stockpile here, doesn't do anything, but it just kind of tells you what it is, because there really isn't a UI component, as it's just abilities to use under the hood. But others have very built-in additional UI capabilities. And so we'll go into debrief later on, but essentially there's graphing and visualizations done within this subcomponent. But anyways, this is where we list our plugins, and this is where they'll show up if they have been successfully loaded into Caldera. And then at the bottom, we have additional configuration. So this configuration is different from the configuration file I showed you, as this configuration is more, or is dedicated to the configuration of operations that we will run. And so that's distinct from just configurations for booting the Caldera server. And so I'll go over these later. They'll become, the keywords you see here, or the titles will become more obvious as we get later on into the tutorial. All right, so let's get into one of the foundational components of Caldera, abilities. So abilities is Caldera's word for, you can think of exploits or actions, or steps, however you want to think about it. But when they are used, abilities are essentially an action done by an agent on a host as a part of an operation. What we're seeing here is essentially a simple search interface and dashboard for all the abilities that Caldera has loaded in when it was booted. And so the majority of these abilities are from that Stockpile plugin that I was mentioning before. And the other majority is from Red Canary. We have all of the abilities ported from Atomic Red Canary. And so together we have about 450 445 abilities that are at our disposal. What you see in our search filters here are just ways to narrow down and filter and look at them. You can filter by platform. So essentially this is the operating system of the host that these abilities could run on. You can filter by plugin, which is what I just mentioned with Stockpile and Atomic Red Canary. And then you can also filter by attack, tactic, and technique. I don't know if everyone's familiar or not with MITRE's attack, but MITRE, well, it's pretty highly branded, but if not, MITRE has also put out for many years now an attack matrix to essentially model and discuss cyber operations and attacks, both from an offensive and defensive perspective. And so essentially every ability in Caldera is also mapped to this matrix. And so you can see that really simply in the abilities. We have the, this is the tactic. Tactic in this little, I guess it's a black highlighted box here. But also you can filter on the tactic as well as the technique if you are thinking about these in regards to the attack matrix. So yeah, so let's go ahead and click on one of these just to see what they look like. If you click on, what would be a good one? We'll say credential access. If you click on the abilities, essentially you see the entire ability object and all the fields that are associated with it. You know, we have everything from a unique ID to the name of it, description. Again, it's a tactic and technique, technique name, some other options about it. I won't go into singleton and repeatable. Delete payload is pretty straightforward. Since this, I guess this ability doesn't use a payload. I don't know why that's highlighted. But essentially, if your ability does include a payload, you can set the option here to delete the payload once the ability or action has been done on the host. But that's why it's highlighted here. And then going down here, this is essentially the meat of the ability. Executors are the executors on the host. So essentially they map to platforms. So for the Linux platform, we have the SH terminal or bash executor. We have other ones for other platforms. So for Mac, right, it's Darwin. But essentially, executors map pretty highly to platforms. And so by executors, we're saying, okay, how do you run this command or this ability on this target platform? And what command is it? So this ability, which is just to access the password file on a Linux system, the command is pretty simple. Essentially, we're catting the password file, moving it to a text file, and then catting that text file. And so this is the actual command that will be run on the target system. The agent essentially will get this ability over the network as a tasking. It'll run this command, get the output, and then pipe it back. We'll show that here in a couple minutes. Some other fields that we can set on abilities, which again will make sense more later, but requirements. So this is really important for planning, and some of the planning stuff we'll show later for the automated planners. But essentially we can, on any ability that we run, we can set preconditions and say like, okay, this ability can't run until we get certain facts or pieces of information. And that's usually because the ability requires that piece of information. And so one that comes to mind is, right, like you can't exfil a compressed data or a file directory if I haven't compressed it yet. So a requirement for that ability would be, okay, you need to have a compressed directory first before you exfil it. So by this way, we can kind of set preconditions on the abilities, and they're manifested in the operations. And then later we'll talk about planners, where planners can actually abide by these implicit requirements, you know, pre and post conditions, but they can also manipulate and change them if they want for different types of planning logic. Finally, these last fields here, timeout is just how long to wait for the ability or an ability or action to complete on the system before marking it as successful or not. When we run the operation, you'll see, but essentially if this isn't complete within 60 seconds, the server will assume it was an error and it didn't work. And so it'll mark that action as such. This command also has a cleanup. So essentially after the command here is run, And after it pipes the information back to the server, it'll run this cleanup command. Essentially, it's cleaning up after itself, removing any evidence. A lot of our command or our abilities have cleanup commands associated with it. Cleanup commands will also be run like kind of automatically if the connection gets severed between the server and the agent, or there's a remote kill from the server to the agent. You know, the agent will get the kill notification, but it'll say, okay, I need to do all my cleanups first, and then I'll go ahead and shut down. And then lastly, our parsers. So our parsers are related to our requirements. So essentially, if we want to take information that comes out of this action, you know, this ability when it is run, and create facts from it that are used in other abilities, we do that through parsers. And so essentially a parser is we are binding or piping the output of the command through this parser, which will attempt to parse out the facts and create facts and add them to the operation so that these other abilities can use it. So you can see all of that is configurable here within the UI. And you can also add additional executors. So if you have this one ability that works on multiple platforms, you can specify as such here. So I'm going to go ahead and close this out. And so I think, okay, so I'm going to go ahead and walk through creating a new ability, just so we can go through that process, and hopefully we can also use it later in an operation. But if you want to create a new ability, we have this red kind of banner button here to create a new ability. By default, it'll fill in the fields that it expects. And so I'm just going to run through and kind of fill in dummy fields here. Yeah, let's do that one. You do have to specify these attack fields just so that it can tag the ability and work correctly in like the search interface, as well as some other mechanisms within Caldera. So I did have to fill those out. I just picked random ones. I'm going to later run this on Mac, so I'm going to choose a platform as Darwin. That's fine. I don't have any payloads. And so my command, I'm just going to make a directory. Let's see. Make sure it's clear. All right. Make a directory in my temp file. I don't have any requirements. We'll have it time out after 20 seconds just to have something different. And then my cleanup command will be just to remove that directory. All right. And I'm not going to do any parsers for this one. All right. So that ability should be here. Yep. So now our ability shows up in our search interface here. It should be available to our operations later. But yeah, so that's all I had for abilities. I was gonna take a brief pause to see if anybody had any questions for abilities before we move on to adversaries, which is kind of the next building block. And thank you, Ron, for filling in context.
Yeah, just trying to translate from cyber to Fleming for people.
Mm-hmm. Yeah, please ask questions, as I talk about this 100 times a day, and so it's obvious to me.
So I have one question about the what Ron wrote in the chat. So you said the parsers are like effects, and then the requirements were like preconditions, but are they like talking about the same thing? So like is the requirement requiring something that a parser will add?
Yes. Yeah, that's a Michael can explain it better, but it's adding the facts into the data. The parsers are adding the facts into the database.
Yes, and there is a, where is it? There's a good sub-documentation on that. Okay, maybe this is, I thought it was called How Caldera Makes Decisions, but I don't see that. But I think this would be good. So this is on our Read the Docs page, but essentially we talk about requirements here and parsers, and so this would be a good page to look at for requirements. Here we go. Oh, there is it. An operation results. No, that's not it. Okay. Yeah, so I'd say take a look at this requirements page, but essentially this is the ability as defined in the YAML file. We have, here's the command, and then after we say here are the requirements for that command. And so you can see here, this is a requirement for paw provenance. I'm not familiar with that, but essentially the source is, the name of the fact is, it needs to have a host username fact available. And same thing down here, you have to have a password available. And so you can see here the variables here in the command that will get filled when those requirements are met. So, when Caldera is operating, it'll say, can I run this impersonate user ability? And it'll say, well, what do I need? I need these requirements. Okay, do I have host username? Do I have host user password? Oh, I do. Okay, now this ability is available. And go ahead and take those information that we have and then fill those variables within the command so that it'll work. And essentially, just like you said, on another ability, there's a parser that is specified that creates these facts. I just can't find the docs where we, oh, is it parsers? Yes, here it is. We changed the title here. But on this parsers page, here you can see in the definition of the parser, this is a basic parser. I won't go into how we group our parsers, but essentially, when this parser is binded to an ability, the output will be run through this command. Essentially we're doing, oh, sorry, that's the command, not the parser. The parser is defined elsewhere, but the parser will be applied to this command or the output of this command, and it'll create a fact in a relationship based on the output if it can find the patterns that it is looking for. And so this command could create a two facts, a host file path and a host file extension, and then with the relationship just to denote what those how those two facts are related. Did that mostly make sense?
Yeah, I think I got the main point. Thanks.
Cool. Okay, so any other questions on abilities before we move on to adversaries? Great. So adversaries are pretty easy. Essentially, there really isn't any nothing formal about an adversary except that it is a set of abilities in an order. And so we have quite a few adversaries that come preloaded with Caldera. We'll just look at one real quick. We have this really cool updated interface here to look at the adversary. And so I'm just looking at an adversary called Advanced Thief here. This adversary is essentially just composed of 3 abilities. That's what you see there with the order, the 3 kind of rows here in this table. It'll do a file search, it'll compress what it finds, and then it'll exfil it. So it's a simple thief. I don't know why we call it advanced thief. Maybe there's an even simpler one. But anyways, what you're seeing here is the adversary. Really, it's defined by just a list of the IDs of the abilities that you want to run for the adversary. So if you want to create your own adversaries, it is very easy, very simple. I won't go into it, but you can click on this and select a profile to kind of start with, and then you can manipulate it and add to it. Our interface here is highly manipulatable, so we can change the order right here if we want of these abilities. We can also look at our pre and post conditions that we talked about before. So I really love this feature, but if you kind of hover over any of these rows, you see the pre and post, the requirements from one ability to the next. And so essentially for, compress the stage directory, it has a requirement. And so if you hover over that requirement, you can see it highlights, okay, this is the previous ability that needs to run. And that ability, of course, needs to be successful. So you can see there it's highlighting that our first ability actually unlocks the availability of our second ability to run. And it kind of cascades from there, because 2 also unlocks 3. But anyways, that's a really cool feature. Our kind of heads up display also shows you again, the executors are essentially the platforms that our abilities can be run on. This means that this is what is currently defined in the ability. Of course, if you want to add to an ability or enhance it, like for advanced file search, there is not an executor here for Darwin. But if you wanted to add that and you did add it, then that icon would show up here showing that you added an executor for Darwin. We also just note if any of the abilities come with a payload, as well as if they're going to run cleanup commands. So pretty cool. We also just have a color breakdown of the tactic, the attack tactic. It's obvious here because we only have 3 abilities, but in larger adversaries, this is just a neat summary of all the abilities that it's running. We also have here the fact breakdown. And so it essentially is just telling you about the facts that this adversary uses and whether or not they are required and whether or not they have been collected. On this adversary, you might be asking, why does it already have collected facts? And so the answer is some are, when operations are run, we have a kind of basic facts store already. And so these 2 facts, stage directory and compress, aren't dynamic in a sense, and so we can just have them statically defined, because we're going to, we can, for instance, in this adversary, no matter what files we find in the system, we can say that we're going to compress all those files into this stage directory with this name. So we already know that. And I forget what compress is actually showing, whether it's a Boolean or if it's the actual, oh, sorry, that's actually just the compressed file name. And so we know that file name ahead of time, so it's saying we already have that. And so since we've already collected it, but we say, these adversaries or an operation, when you run an adversary, is seeded with a fact base. And so every operation, unless otherwise specified, will be seeded with these basic facts that we know. This adversary doesn't have, looks like any of the other fact labels we have here, required and not collected, and collected but not required. The yellow label is basically for facts that the adversary expects to get when running. So, the 5th ability that it runs might require output from the 3rd ability. And so that would be labeled as required but not yet collected, and obviously it assumes that it'll be collected when the operation or adversary is executed. And then we also have the black label for just facts that were collected but not required. This is just interesting to highlight. We use this just to observe what information we are getting that is not integral to the operation, but nevertheless there, and we have. Usually this is kind of just a flag for, can we use this information that we aren't currently using in more ways. So I'm going to close that. I don't think there's anything else I wanted to go over on the adversary dashboard. Again, you can create your own adversary. You can edit existing adversaries. I would just be careful if you're manipulating our adversaries that come preloaded with Caldera, just because they will save to disk. So just be careful modifying the basic ones. I would add the adversary by starting from another one and then going from there instead of editing the base one. We can also, here's the add ability. So if you want to manipulate adversaries in line, you can also just add an ability. And then here we have save and delete profile. But yeah, pretty straightforward. I will pause there though if there's any questions on adversaries. Yeah. I just changed the adversary. This is kind of a cooler one with kind of more information showing. So you can see it gets pretty useful with all the kind of the UI highlights we have going on. But cool. All right. I don't hear anything, so I'm going to move on. We're going to move on to agents. And so, oh, let me back up. You can see I've been kind of hitting on these hamburger components, and I've been getting a new tile for each. You can see they just kind of stay in the top bar here. You can keep them there, or you can X out of them. There is no effect on any of the information. It gets saved, and so nothing happens. If I close it, I can open it up again and do the same thing. So it's just a feature for easy viewing. But I'm going to go ahead and close those out and go to our agents tab. This is one of my favorite parts of the command server here. We have, essentially we have our command server running, but to actually do anything, we need to deploy agents. Or again, terminology, you could think of it as implant, or you can call it malware or a program. But essentially our agent is going to be what's going to be running on our target host that we want to run an operation against. Or it could be multiple hosts. We can have many agents deployed and run an operation against all of those agents collectively, or for instance, like every agent running the same operation or adversary. But there is a strong requirement of we do have to have one agent running to start an operation. So essentially we're assuming initial access. And Caldera is used to establish initial access. We do have a plugin access there to help with that. But for the most part, we're kind of assuming a post-breach mentality of there is at least one agent running on the target system that is beaconing back to the command server, and we're about to start our operation. So I'm going to go ahead and start deploying an agent here. I'm going to deploy my agent also on my local system, just for ease of for demo purposes. But of course, the main use cases, right, is that you have your server on, maybe your system or actual server, and then your agent is going to be deployed on the actual host, not on the same host. So anyways, I started the deploy process here for deploying an agent. I really like our UI because it makes it so easy. Caldera comes preloaded with 3 different types of agents. By far the most used one and supported one is the Sandcat agent, which is an agent written in the Go language, and has a variety of C2 channels that are available. However, we also have Ragdoll, which is a Python agent, and we have a Manx agent, which is a reverse shell agent. Essentially, these have different target use cases, but they can have variations on the C2 channels that are available to them, but they all operate in the same way of taking instructions or from the server, tasking and executing that tasking, getting the results, and then piping those results back to the command server. So there is parity in that regard. However, there's not parity in some of the features. Again, Sandcat is the most built up with the most C2 channels, which is essentially different ways of being stealthy. So I picked my agent. Again, I'm on a Mac, so I'm going to pick the Darwin Executor. The first main configuration you see here is basically give me the contact address of the server. Again, I'm running my server locally, so this is my local host URL or IP rather, and port for the server. The next field is the implant name. You can change this to whatever you want. Our default here is Splunk D. So if anyone's not familiar, Splunk D is just the name of the Splunk daemon. So naturally, usually folks that run the SandCat or any of the implants don't have obvious names, so they'll name it something that is stealthy on the system. We just have it as Splunk D, so it looks like it's the Splunk daemon on the target, but you can change this to whatever you want. You can also add extensions, file extension names if you want to the name itself. So those are kind of our three major configurations. And then below what you see are the commands that we're going to run on our target host, which I'll show, to get our agent up and running. But you can see there's kind of different options here. And so all this really is just further options on how you want to run the agent. The base one is the first one shown, which is, all right, run the agent and communicate through an HTTP connection. And that's it. However, you can see we have variations here. And so essentially we can deploy our agent as a blue team agent instead of a red team agent. We won't get into blue team agents today, but essentially with Caldera, you can also run agents that are good and are actually trying to hunt and find the red agents. So if you want to flag this agent as a blue team agent, not a red team agent with some different settings, this is the command you would run. If you want to run the agent with a random name and start as a background process, this is the command you'd run. You have different C2 channels down here. Deployed as a P2P agent. So again, really just all different configurations of running the agent. The underlying functionality though is the same. They're all going to take tasking, run it, and then pipe results back to the server. I'm going to go ahead and just do this first one here. So I'm going to go ahead and copy the command here. I'm going to switch over to my terminal again. Okay, and so I'm just in a directory that I use for running agents because they will pull the payload down. So I'll go ahead and remove my previous agent that I have there. So I'm just going to copy this command that or paste, this command that I copied right here. And so again, you can see the command is essentially just pulling down the agent payload from the server, but it has it all pre-configured, so you don't have to do anything. So we're just going to go ahead and press enter. By default, our agents will be nice and verbose, so you can see what's going on. Of course, if you run as a background process or change stuff, it doesn't have to do any of this. But we have success. We see that our agent has beaconed. It is already actually running an instruction, which I'll get into in a second. And it's also actually piping the results of that first action back to the server. But this, you can see our agent is up and running and beaconing. If we were to stay on this terminal when we run an operation, it would also show you that it's running further tasks as the operation proceeds. However, it looks much better in the on the command server UI, so we're going to switch back to the browser. All right, so I'm going to switch back here. So I'm going to close out of this screen that we were looking at to start the agent. And then, as you can see, our dashboard here of agents has already populated. As soon as that agent beaconed in, this row here got initialized. So essentially, this is just a nice heads-up display of all the agents that are connected into Caldera and what their status is. And so every new agent that you have will populate a new row here. All the primary information is kind of shown. We have the ID of the agent. which is not a big deal if you're running one agent. However, if you're running dozens of agents and they're hitting the same host, the ID becomes very important for identifying them and managing them. We can see the host that it's on. This is the actual host name of my MITRE laptop here. The group of the agent. Again, for this demo and for a lot of the use cases, the group doesn't matter. But again, if you're using dozens of agents and they have different purposes, you can group them so that it's easier to manage and organize. We have the platform, again, the host operating system that the agent's running on, the contact it's using, the actual process ID of the agent. So this is super useful for whatever reason. The agent runs amok somehow. You can find the process on the actual target and close it up yourself. I've never had this happen, but we put it there just in case. We also showing the privilege of the agent on the system. And then we have this live status here of the agent. Alive means that it is beaconing in, and then trusted means that this is an agent that we're expecting to, sorry, the agent is operating correctly and we are getting expected results from it, so thus it is trusted. You saw that I clicked on the row before, but if I click it again here, we get all the agent details again, but we also get some settings that we can change on the fly. So we can change our I guess we can't change it right now for some reason. But on some agents, we can change the contact, basically the C2 channel that it's using ad hoc. We can also change the group. We can change its sleep timer. I thought we had, okay, we don't have tooltips. It must be on another visual here. But we have timers here. So sleep timer is essentially the agent, how long it'll sleep between kind of asking for instructions. So this becomes very important for different stealth tests on a network, especially for any like, you know, endpoint detection tools or network security tools that are looking for static beacons from agents, you know, going out of their network. We put a min and max so that you can set a range so that the timing is random. So again, a little bit more stealthy. And then our watchdog timer is, we have another timer, I'm getting confused. I believe this is when, actually, let me close out of this. I wanna see, yeah, oh, here are virtual tips. So our watchdog timer is how long the agent will stay alive once the connection from the server has been disconnected. And so it's by default set to 0. So if it loses connection with the server, it'll go ahead and shut itself down. However, you can change this. The other timers, like I mentioned, were the beacon timers for when it beacons home. The untrusted timer is for the server. So if an agent doesn't respond in an amount of time, it'll label that as untrusted because it's an unexpected behavior of the agent. We also have, went over an implant name, bootstrap and deadman abilities. These are just really cool abilities that you can set the agent to run kind of autonomously and automatically. So bootstrap abilities are abilities that are run immediately without any tasking from the operation or the server. So that was actually the first action we saw the agent run. And so it was running an avoid logs action or ability. And so it basically stopped the terminal from logging history. And so that's what it ran immediately. We can also have deadman abilities. So if an agent gets terminated, it'll run all these abilities before it actually shuts itself down just automatically. So just neat configuration you can do here on an agent. I won't change any of these for our purposes. And also you can kill the agent. Oh, hang on, that didn't kill it. Oh, maybe it did. No, it shouldn't have killed it. I'm looking, maybe that was the kill. I thought it did a "are you sure" window, but maybe we changed that. But what I was trying to show is you can kill the agents, and you can also kill them in bulk. Yeah, like I said, I didn't kill the agent. This just exited out of the view here, and it repopulated because the agent just beaconed in. However, if you do want to kill the agent, it is down here at the bottom of kind of the subtile when you click on the agent. And so if you do that, it'll immediately shut down the agent. And again, the agent will run dead man abilities if they're set, and it'll also run cleanup abilities if they're set. But yeah, I think that's everything I wanted to talk about agents. So I'll again take a pause if there's any questions on agents.
I have one maybe a bit stupid question, but I didn't quite get like who's running agents. Like what? So you have a red team and a blue team. Is like each one of them running one agent, or what's the scenario there?
Sure. So let's just go with like the red team use case, right? So if I'm testing the defenses of a system, or again, for whatever reason I want to run an offensive cyber operation, I would be a red user, right? Because I'm just trying to play offense. And so in this case, I deployed an agent and I'll run an operation. And my agent is in the group red. There again, really isn't too much formality besides it just being a group name. And Caldera knowing like, okay, this is meant to run adversaries and operations. The blue team agent, which I'll say is not as built up as the red team agent, is again, I can deploy a blue team agent from the UI here just as easily in the same way I'm running a red agent. But a blue agent essentially is very much the same thing, except its objective is different. And so our blue agents can run essentially like the defensive equivalent of an adversary. So it can run actions that it's trying to defend or hunt for malicious behavior. We have the original impetus was for the blue team agent was we do have another plugin called Game Board, which allowed us to run both a red agent and a blue agent on a system, and we could put the agents kind of against one another and run experiments. So the blue agent would be running a certain strategy, essentially certain actions, hunting actions, and defensive actions like killing rogue processes, looking for malicious behavior, doing alerts. All the while, our red agent would be carrying out an adversary's role and doing all the malicious abilities that we've seen here. Does that help?
I think so. So are the agents here like attacking an actual system or like a simulated system? So is Caldera the playing field, or is it the staging ground for the agents?
Yeah, so this is on a real system. So this isn't an agent, essentially it is malware or an implant, and it is running on my own system. So it is not, so Caldera is not the environment. It is the command server and the agents and kind of the platform to run these offensive operations. And so it's essentially a suite. But it is running on, so I'm running the server both on my system, and then I deployed an agent also on my system. But it is not the environment. The agent you see kind of beaconing here is a real agent running on a real system, no simulation. And so when the next thing we're going to get into actually is running an operation, and you'll see that it is actually running these commands on a target system, my system. But again, it'll be an operation that's not too malicious, right? We're going to run a discovery adversary, so it's just going to try to find things. But yeah, so Caldera is the platform. We deploy it onto systems. Essentially, we would deploy our agents on these target systems that we want to evaluate. So like for instance, a lot of our users are defensive operators that work in SOCs, security operations centers. And so they will run the Caldera server like on their work servers, and then they'll deploy an agent onto a host within their network that they're defending. And then they'll run an operation to test their defenses, their network defenses and their host defenses that exist around that target host where the agent has been deployed. And then they'll check to see if they can catch the agent while it's operating.
So there was another
I
question
think
there that Florian had in the beginning, which was, how many agents does the red team run?
Yeah, so it can really up to as many as you want, given that Caldera can support it. So we do have I think we have a scalability cap where the server, like we're working to fix this, or not fix this, but just enhance this. But it can run dozens of agents, no problem. Conceptually, you can run as many agents as you want on the red team. Again, it just becomes an organization and kind of use case question about how, like, what's your objective? So we have some users who want to run the same operation or adversary on every host in their network. So essentially, let's say they have 500 hosts. They want to run the same adversary or the exact same operation on every single host, and they want to do it at the same time. So they'll have a script that'll deploy 500 agents. They'll all beacon back into Caldera. They'll all be listed here, and you can run the operation, whatever the adversary profile you want. We'll say thief. You want to run thief on group red, and so it'll run the operation against 500 agents, sending each one of those agents the tasking in order, and then getting the results back. We'll see here in a second that the operation UI is currently really built for looking at low levels of agents, because if you get 500 agents, right, it's a kind of essentially a nice log. But it's not ideal for looking at that many agents. So usually what happens is, and again, I'll show this as well, but with large sets of agents, they will run Caldera kind of programmatically, not look at the UI, and then dump the operational results, which we dump through JSON, and then do post-analysis that way. But yeah, so conceptually, you can run as many agents as you want. Technical limits of the Caldera server, and just based on the architecture, is we've seen dozens, probably to like a low hundreds of agents be supported. Essentially, the server just gets too busy, and so that's one of our threads that we're working on this year, so it can handle many more agents simultaneously.
So another thing I'll add to that. Yeah, so another thing I'll add to that is that I put it in chat too, is that there's generally one agent per computer, right? And agents are also allowed to start new agents on other computers, and that's you'll probably refer to that later as lateral movement, which allows you to spread your control through the network.
Yes, no, great point. Yeah, so the operation we'll show here in a minute. I won't spread anywhere because, again, I'm just doing this locally on my host, and so doing lateral movement on VMs on a demo, I don't have too much success. But yes, we do have, obviously lateral movement abilities that spread, from one host to another. And so that spread is essentially creating a new agent on, the target of that lateral movement. And so as an operator, if you start on one host and you run an operation that's focused on spreading, Alice, our Alice adversary is actually focused on that, it'll get more agents over time because it is compromising more hosts. And then those agents would pop up on this display, and then an operation would be triggered to start again on each one of those agents. So essentially, you could have a exponential operation going on until you've saturated your ability to laterally move throughout a network. But yes, usually it's one agent per host because it gets messy, and I don't think we've had use cases where where users want to test, if they can catch 2 agents on a host, it's usually just trying to catch the 1 agent. But also just from a control perspective, we have, it does get messy sometimes of running multiple agents, or when agents just end up on the same host and then have to deconflict. So usually I'm pretty confident saying users like to stick to 1 agent per host, just because it keeps things clean and serves their purposes. Yeah, good questions. Any more? Okay, great. I'm going to go ahead then and switch over to an operation. So again, we have to have an agent running in order to run an operation, because again, that's kind of the foothold of where the operation begins. The agent is, the executor, right, and an actual manifestation of the operation. So I'm going to go ahead and create an operation. Again, this is one of probably the best parts of Caldera, is that the UI here for starting an operation is very easy and intuitive. So I'm going to go ahead and just do fill out these dummy fields here. Obviously, if you're doing this for real, you want to fill it out with a descriptive operation name, as you might be running a lot of operations. I'm going to pick the discovery adversary, because it tends to work well in demos, and it has lots of good results we can look at. We've sort of hit this before with the questions we've had about requirements and parsers, but essentially for an operation, we can also preload it with facts and information for it to use. By default, usually all operations are seeded with this, what we call our basic fact source. If you remember when we were looking at the fact breakdown for an adversary, excuse me, we had facts that were labeled as collected and required and collected already. And so essentially those came from a fact source that was already seeded into, that would be already seeded into an operation. But the real use of this, or power of this, comes when you run multiple operations and you want to use kind of data and information you've learned from past operations. So you can run an operation, right, save the report, and then take the report, load it back in to Caldera, and that fact source becomes available for further operations. So essentially you can build up your knowledge that you have of a target environment that you've been running operations on, and you can seed that information into operations, so you don't have to keep starting from scratch. But that's what fact source means here. We're going to keep it basic for the moment. You see here we have an advanced submenu here. I'm going to go ahead and click it. These are all just further configurations we can do on the operation. Again, by default, the operation will be running against all groups of agents. Again, I only have 1 agent running, so this doesn't really apply. But if I did have multiple groups, I could down select to a certain group if I wanted to restrict the operation to just that group. This becomes very important if you're actually doing defensive operations and want to put on digital fences to where the agents that are actually operating at any given time. I'm gonna skip over planner for the moment, because we're gonna get into that later. The obfuscators are essentially, do we want to encode the commands or the actions that we're tasking to the agent over the network? So if we change this, it'll actually change the encoding. Again, this is really just a stealth mechanism that you find in a lot of real life command and control channels for running offensive cyber operations. So we offer that here. You can also add your own encoding too. You can just add plugins to Caldera and they'll show up here as well. The other options we have here are kind of about running the operation. So autonomous just means that once I start the operation, it's going to run on its own. If I don't want that, I can require manual approval. So basically, this will step through one action at a time, basically requiring a human to select yes on every ability or action that's run. A lot of our users like this if they're in safety critical systems or just kind of high stakes environments that they're doing tests in. So they know they can, they have to approve, and Caldera won't do anything that it doesn't explicitly want. Parsers, again, we have the option here to turn off parsers if we don't want to parse information from our actions that are run. I haven't come up with, I personally haven't come to a use case where I've turned this off yet, but if you want, that option's there. Auto close is essentially, do we want to keep the operation open forever, even if it doesn't have any actions to do, or if we want to close it after the adversary is done running, or all of the actions that are worked through. I'm going to go ahead and put auto close. A reason why we would want to keep it open forever is a lot of users will run an operation, which will say, let's say it has 10 actions. It does those 10 actions, but then at the end, they want to possibly run more actions ad hoc or redo certain actions. And so this will just keep the operation open and allow the user to say, hey, run this action again, do this again. So it just gives a lot of flexibility if you're actually testing defensive mechanisms. And you'll see that in the UI here for once we start the operation. Again, another kind of operational feature here is to run immediate or pause. This is used, again, usually by defensive operators or researchers who are experimenting, where they want to prep this, get it kind of preloaded, but then they also have to just start other services and possibly experimentation infrastructure. And so they'll do that and then just press start here. So it just kind of helps them with experimentation and testing. And then lastly, our jitter. This is how we'll change the agent on how it'll beacon back. And so essentially, when it'll ask for new instructions or new tasking, as well as when it'll pipe back the data. We'll keep this low so that the operation just runs faster for our demo purposes. But again, you can change this to whatever you want. Again, it's a min and max because it'll pick a random amount of a random integer between those two, and then use that for every instance. So again, it's a little less predictable. It's not beaconing every 5 seconds exactly, which is usually a red flag on a network. Our last feature, visibility, doesn't do anything. So I'm just going to tell right now, this is not really plugged in anything yet. Our intent is that by changing the visibility, you could possibly change the way certain commands are run, as well as, change the way certain abilities are run, if they're even run at all based on this visibility setting. This is not it's not plugged in anything right now. It's kind of actually a complicated problem. But it is a feature that we're looking forward to. But for now, it doesn't do anything, just for awareness. But I think we're good. So I'm going to go ahead and start this operation. Again, I'm not going over the planner here because I'm going to hit that in our next section. So we'll just go along with that for now. But I think I'm ready. Yep, my agent is still fine. So I'm going to go ahead and hit start here. So this is also, again, one of my favorite views of the server. We are looking at a live operation that is running. Essentially, what you see is it's a table that grows downward of every ability or action. I'm using those terms interchangeably because essentially an ability is an action when it's actually executed. So the table here is live, and so it is kind of showing the full progress of the operation. The first ability that it ran was to identify the active user on the system. And so that ability was collected by the agent. So that's what that color means. And then you can see it just changed. So basically what we saw was it was saying, okay, the agent received its tasking, and then it changed to success because it actually executed, got the results, and piped those results back to Caldera. There's a server here. The server parsed it and saw that it was a success, and then updated our dashboard here. And now it is moving on to the next action or ability that's within its adversary profile. Again, I'm running a discovery adversary. So essentially, it's all abilities that are associated with finding out as much as it can about the target system. And it is also in an order that is conducive to later abilities running. So if abilities require have requirements for certain facts, those abilities will be run later or after abilities that produce those facts are executed. So again, we're here just looking, you can see that the operation is proceeding. I went over most of these fields here on the table. For convenience, for every ability, you can also just view the raw command that it ran on the target system. The active user, right, is pretty simple. It's just running a whoami command. But you can also look at the output. And so in the output we see here, this was not only the output, but the output was my username, Kouremetis, but it also shows you the facts that it created from that output. So super cool. We're seeing, these parsers in action, as well as these kind of preconditions being fulfilled for later abilities. And you can see here for some of the more advanced commands, we get better and better output. So it found users, now it's looking for IP addresses and network config. The discovery is pretty cool. It'll eventually get to like browser bookmarks and sensitive files. It'll just try to look for anything of interest. So I've kind of gone over this table now. At the top of the table, we essentially just have our control of the operation. We can pause it if we want. We can stop it outright. If I hit stop, it'll actually stop and then tell the agent to run up any cleanup commands. Then I'll run any deadman ability, or no, sorry, that's only if the agent is killed. So it'll just run any cleanup commands and then stop the operation. We can also switch to just run one step and pause again. And we can also just change it to full manual over here if we want, where every action will be need approval by the human operator. So yeah, so again, just looking at our operation proceed here, I'm gonna let it run for a minute or two. But while that's going on, I'll pause for any questions about operations.
So you mentioned planning. Are the steps just following a fixed sequence, or is there planning going on to decide which steps to run?
Great question. So yeah, I'll hit this in the next section. But right now, it is essentially running this adversary in order that it is listed. So if you go to the definition of the adversary, which is just a YAML file, it has all of these abilities kind of in this order. I will note though that Caldera will change this ad hoc if it sees that the next ability doesn't have preconditions met. So with this adversary and with a lot of other adversaries we have that our users find very useful, what they want to do is very can easily define, the conditions are easily defined, and so it's not a big deal that it's a static order, because that's the order they'd expect. We do have some adversaries that kind of will implicitly branch because it didn't get a piece of information it needed for this ability, so it'll go and move on to this ability. By default, with how it's being run now, it is very simple. It's running what we call the atomic planner, but the atomic planner is just following the general order that the adversary has enumerated. So the most complex kind of decision it'll do is say, okay, this ability doesn't have preconditions met, don't run it, what else can we run? And then if no other abilities can be run, the operation will stop. So that's kind of the level of planning we have here. I mean, if you want to call it planning, but essentially it's just making sure preconditions are met. If they're not, find another ability that can run because preconditions are met. Did that make sense for the moment?
Yes, thank you.
Hang on with me, I'm just re-authenticating to the MITRE VPN here so it doesn't cut me off. Cool. Okay. So again, the operation is proceeding. This is a discovery one, so it's kind of doing a ton of different stuff. I really like this antivirus one. I won't show the output because it shows what antivirus we use here at MITRE, but it did find all of the antivirus that we have in the endpoint. So anyways, it's filling up all this information from this operation as we go here. I'm going to go ahead and stop it just because we get the idea of what's going on here. I will note that if we want, we can add new abilities on the fly. So we can kind of just search our repository of abilities and add one that we want to the operation. We can also insert a manual command. So, you know, say, I don't know, what I want to run ls on a certain directory or something for whatever reason. I can also just add it on the fly here. This is mainly a feature that a lot of pen testers like, because they want to kind of do an ad hoc command that we don't have predefined or it's not defined in the adversary. So again, we kind of give them that ability to do that really quickly there. Also very good for testing. But I'm going to go ahead and stop. And so we've stopped the operation. It'll stop exactly where it was. The agent is still running now, mind you. The agent is still fine. We can look there. Agent is still up. It's just we stopped the operation that it was currently running and told the agent, like, we're done with that. Stand by for future instructions. So once we have stopped an operation, the biggest value we have now, besides just kind of looking at our action table here, is doing post analysis. And so on our operations page, immediately we have the ability to download a JSON report, which is a giant JSON blob of all the information about the operation that occurred. So I'm going to go ahead and do that. We have just different configuration options if you want to keep data in or out of the report. I'm going to keep it the full report for now so I can show it all to you guys. So I'm going to go ahead and downloading it. Let's pop it open. Oh, it popped open on a new screen. Give me 1 second to switch windows here. There we go. So this is a JSON report of the operation we just ran. It has everything, everything from the host information where we ran the agent, the adversary that we ran, again, just all of the information there. We didn't have objectives or goals, which again, this kind of goes into planning, which we'll get into in the next section. But if we had those, they would be listed there. Facts. So this is pretty cool. This is all the information we learned. So I think there's like 400 just based on the discovery adversary that we ran. If we open up a random one, we can see all of the things. So it's a lot of these are just certain host file paths that are deemed interesting, but it'll also have users, bookmarks, all different types of things. And if you notice, it'll also specify the type or the origin. So this fact was learned. And so this goes back to before when we talked about seeding operations with facts. If the fact is seeded, it'll say as such. If it is learned, it'll say as such. Or if it's just default, it'll also label that as well. But again, a lot of just very rich information to run post analysis on whether the information you've learned, but also the steps. The steps here are essentially everything that you saw in the UI before, but just in JSON form. So, every action we ran in order, what time it ran, where it ran the platform, the attack matrix information. We have, am I missing output? Oh, I didn't specify to include agent output, but if I did, it would also have all the output. for every action that was done, so what was produced by that action in raw form, as well as, encoded in the facts down here. So anyway, it's very useful JSON file. A lot of our users run, hundreds of operations, and of course, they don't look at the UI. It's cool to look at for specific, but if they're doing kind of programmatic testing, they'll just dump the JSON and run it through their post-processing and kind of analytics. So very cool. I'm going to stop there. I'm going to actually, the next part I want to go over is an extension of kind of doing post-analysis with our plugin called Debrief. But before I do that, I will pause if there's any questions on the operation that was run and just that JSON that we looked at.
Do you have any links between facts on that one to show?
I don't think so, because none of these required links.
Okay.
I could do a collection one. So let's, hold on. Good question. I can start a new operation. Let's make it really fast. Let's see what happens here. So this one will have links, or preconditions, because essentially you can't exfil files if you don't find any or pre-stage them. So let's see how this goes.
Oh, and just for another translation between like Caldera and planning terminology, facts, like the user, is like host.user.name corresponds to like a PDDL type, where like like Kouremetis would be the a term for that type, and the links between facts correspond to like a triple of connecting two terms together.
Yes, yeah, and I'm not going over our facts terminology too much, as it is an action item this year, and so we plan to do a lot of work with really how we refer, kind of our information model and facts in our knowledge store. But we hope to have better documentation. We have okay documentation right now, but in the future, we want better, so that we can really enable more of these automated planning use cases that we in the past haven't done too much of. All right, so it's working through. It's just finding files for the moment. Yeah, please feel free to ask any questions while we wait for this one to complete. So I can also show, because you might be wondering how these adversaries are defined. And so if you go to the stockpile plugin, which again is really just a stockpile of abilities and adversaries that are already defined, and we go down to just a random adversary. That's not a good one. You can see this is essentially all that is really required. And so this adversary is called Nosy Neighbor. Its purpose is to find Wi-Fi networks. And so the actions that it'll take are defined by these abilities. Each of these IDs just coordinate to an ability. And so if you looked at these IDs, you would see the specific abilities that are run. Again, by default, adversaries are defined in kind of a static order. And Caldera will run them in that order. But if it gets to one that doesn't have a link, or sorry, a precondition met, or in our terminology requirement, it would not run it and look for others to run. But again, we'll get into planning in a couple of minutes, which essentially is a layer on top of this, allowing you to manipulate all of this order and logic for running the operation. Yeah, you can see we have quite a few adversaries just available, and of course we can make infinite permutations of the 400 abilities that we have to make new adversaries. Okay, yeah, so here we have, I believe this was a requirement. So here's a good demo or a good example, Ron. So this actually command timed out. So for whatever reason, so it's marked as such. However, the create staging directory wouldn't have run without the any files being found. And then the next one we should see is the running of the exfil, or sorry, the compressing of the staging directory and then the exfil, which are essentially all successive because they require the previous ability to be run. I'm waiting for the next one because the next one should have a, within the command, it should have a variable which is essentially referencing a requirement. Interesting, did it not? Ah, okay, so I guess, okay, this is just collecting, sorry, it's not actually exfilling. So it looks like it did complete. It did complete, and so it's just kind of the operation is staying open because we said it open forever. But there were, keep doing the wrong tab here. There were links between requirements and preconditions. Wait a minute, did I do find files?
You see how those facts showed up in the database?
Yes, hold on. Oh, interesting. Okay, so here's some requirements. It didn't run these first two commands because it didn't find users. So there's an example of abilities not being run based on prereqs. So essentially, this adversary did have two abilities, company emails and IP addresses, but since the operation wasn't seeded with these facts and or didn't have other abilities like finding usernames, it didn't run these two abilities. And so you can see here in the operation, it went right to finding files. There's actually three variations of it, and then one didn't work, and then it's created a staging directory and then completed. Yeah, I should be able to go down to fact sources. So we haven't really gotten to this advanced kind of submenu here, but I just clicked on fact sources. If I select a source, wait a minute, let me stop the operation, and that should show up on. Why isn't it showing up? Okay, so that operation should be showing up here. I'm not sure why not, but we do have the previous one. So yeah, it found a bunch of facts here. And so here are all the facts from the operation. Since it did do discovery, I'm not going to pause on this page because there might be something from my system that I don't want showing. But yeah, it did fill that facts source. And I was going to show in the debrief plugin as well the facts run. But is there anything else you wanted to see for kind of showing the prereqs?
So we probably don't have relationships between these facts. So you had the fact page, but not the relationships, or would that be in the output for any of these?
That's a good question. Oh, there, finally, ICAPS collection showed up. I don't know if oh, here we go.
Okay, so has extension, host file path, file sensitive extension. Okay.
So not kind of super helpful on how we should display it currently, but you should have those relationships in the downloaded JSON, and I think we might show it in our debrief plugin. Again, this is a big action item for this year, and so a lot of this might be changing how we view this and how we refer to it. But yeah, so we have fact, and we didn't go over rules, but rules are listed there as well. Yeah, and then again, you can access everything. Let me look at the operation report real quick. Hang on, it's on a separate window. I'm just trying to see if it was there what we wanted. Yes. Oh, cool. Yep. I think this is what you were wanted me to show, Ron. Let me change windows here. So you see here, I'm showing the JSON report of the operation again. I've kind of dialed down facts, and we have one fact here. It was seeded, I guess, but it does have relationships, and so you can see the relationships fully kind of explicitly put in a string. And if we have, no, okay, it's just a one-liner. Yeah, so we have the source, the relationship, and then the target. And so this is just saying this host file path has an extension of YAML. So again, this one's not super exciting, but we do have others. Extensions
it shows the triple pattern though. So
yes, yeah, yep. This, I was just gonna say, this relationship is just important because we look for files based on sensitive files or files of note based on their extension. So this is the relationship that we fill for that. Yeah, so that's a good example of that. Thanks, Ron, for reminding me. Probably a good idea to share that at a planning tutorial. All right. Okay, yeah, so I'm going to show the debrief plugin, which is essentially a nice visualization plugin for everything that we've been looking at so far in this report. So I'm going to go ahead and pick the operation that I just ran. And so you see we kind of have a graph pop up of the operation itself. This is the attack path. Again, since we just deployed one agent on one host and ran an operation on that host, only one host shows up and our server shows up. But if we were to do lateral movement and we did pivot from one host to another, we would see that here. We also have steps. So this is the actual actions taken. The static view is okay, but we can also play it out if you want to kind of rewatch the operation. Again, and so we have the actions here. Because the graph gets too messy, you have to hover to see the information about it, but you can see the steps that were taken. So obviously this also gets more interesting when you have more hosts. And then you can also break it down by attack field, so attack technique and tactic here if you want. But it's pretty cool, especially for larger operations to kind of see how they run. For our purposes, we also have some tables here below with steps, tactics and techniques, and our fact graph. I'm not sure why this isn't filling up. I'm guessing it's a bug we haven't fixed in our new version yet. But this is what I want to show for our purposes of just showing the fact graph. It's messy and could be better, so we are looking to improve this, but it is here and kind of does give you a rundown of the facts that were created. We're kind of experimenting with how best to visualize and analyze and assess this information, and kind of what's useful, what's not. And again, we can create 400 host file path facts, so do we need to display that all, et cetera. But it is shown here for whatever reason if you want to get a good visualization for it, or put it in a report. I will note that another cool feature that we have here, so we can change graph settings, not going to go into this too much, but we can also download a PDF report of the operation. I'm not going to include this guy. This is really useful for giving to kind of executive project leads or just documenting. A lot of people like PDF reports. So if we do this, we have a kind of a fully configurable PDF kind of creator. So you can rearrange these sections to what order you want, or whether you want to include them or not, but you can also create your own sections and create your own code if you want to add to the PDF. I'm just going to do the default one for now and download it. But it gives us just a nice formatted report of everything that we just did in the operation that we can save, send, and it's actually useful. Again, we see the fact graph here, so like I said, working on ideas to make this better, and how do we view facts and requirements, and do we want to list for planning purposes, our fact dependency chain and how it worked, and our links and relationships. But again, pretty nice feature to create a PDF if you want to give it to a kind of a non-technical person, or just in a cleaner view. But yeah, I think that's it for the debrief. I was going to pause here for any questions, and then we can actually get into planners, which is, I think, obviously of interest to everyone on the call, as well as a good segue into our deception plugin that we want to really show off at the end here. But yeah, anyways, I'll pause for now. If any questions on operations or looking at the reports that we just saw. Okay, all right, so we will move then on to planners, which is the cool stuff. So I will note we do have within Caldera just a planning subsection for selecting planners. It does not do much besides just kind of give you a simple description of the planner. So for parts of this tutorial, I'm actually going to refer to the read the docs documentation, because there's actually a pretty good write-up there. So let's go over there. So let's first talk about, so ignore the text for now that you see on the screen, and just talk about what is a planner and Caldera, and Caldera's architecture. So we saw an operation run where for that operation, we selected an adversary, and then we said execute that adversary and its abilities in the order that are defined as best you can. And if requirements are not met, skip that ability or pick another ability. The Caldera planning architecture is essentially a layer on top of that. And so a user or anyone running an operation can specify a planner to say, okay, run this adversary, which is essentially a set of abilities, but now run this particular planner. and the planner can run the adversary as it's defined, or it can manipulate and make any decisions at once. So for the purposes of our architecture, we leave it fairly open for how users add plan, or we give them flexibility for any logic they want to encode. And so there's no strong requirements there. It's just whatever you want to do, you have to kind of explicitly define it. And so what we do is we essentially build Python modules that are almost like a series of functions that you define, where you can explicitly say what reasoning, what planning reasoning you want to execute. The model we have chosen to just help us as well as users organize their logic is buckets. And so essentially we encourage users or anyone who writes a planner to think in this paradigm, and kind of almost like a state machine paradigm, where you plan on two levels: a higher level, like a bucket. You plan at the bucket level, but then you also plan within the bucket level. So what is, I guess, a good example of this? And so this diagram, I hope everyone can see and read, of a, I forgot what we call this planner. I think it's preferred privilege. Anyways, it's an example planner that we built here for the tutorial, or for the read the docs here. And so essentially this planner is trying to implement an approach that generally follows the state machine that you see. So when it begins, it's going to try to do privilege escalation by going into what we call the privilege escalation bucket. Depending on the results of what it does there, it's going to go into either persistence bucket or collection bucket. And then essentially proceed as you see the state transitions there of this kind of very simple state transition diagram. In this regard, you're kind of, I don't know specific, Ron, you might be better at equating this to certain automated planning terminology. But we're allowing the user to kind of specify as general phases of what they want to do, and then within that phase get into more of the details of what they want to do. For our programmatic purposes, every blue circle you see there is a function. So when we actually define a planner, each of these buckets will be its own function in the planner, and then within that function, you know, a user can do whatever they want, or we can write whatever logic we want. So if we're in privilege escalation, we can do any type of reasoning we want based on what's going on in the operation. Since within our current our design here of this planner, we know privilege escalation is going to be where it hits either when it first starts, or if we're checking if conditions are met and possibly, you know, stopping the operation. And so let me see, do we go into this more? We do. So let me, I don't want to go too specific yet. But anyways, let me go back to privilege escalation. What we would do here is say, okay, I know I'm in this privilege escalation phase or bucket. What I want to do is try to escalate privileges. I have to do that by possibly running certain abilities that gather information about the system or the target, unlock other abilities that I know that are actual privilege escalation abilities. I can then run those and then see if they're successful. And if they are successful, I'm going to leave the privilege escalation bucket and move to another bucket because I've achieved that. So now I want to achieve kind of another objective or bucket or sub goal to my overall objective. And so for this planner, we have, you know, our simple logic is if that's true, go to persistence. And so again, within the cyber domain of persistence is the agent or the operation and campaign is trying to achieve a greater level of persistence on the target host. So maybe the agent is running in memory or something, and it wants to survive in case the host is rebooted. So it'll look to maybe do a startup command or startup script or registry key capability, so that if it is rebooted, the agent will, reboot as well. So, persistence bucket might be all types of logic and subdecisions based on that. And then we get to a point where that's completed, it'll move to collection. And then again, proceed through this kind of state diagram you see here to achieve all of our goals and ultimate objective of the planner. Let me pause there before I get into the nitty-gritty of how we kind of codify this in actual code and run it. But any questions on this? And it's obvious to me, but I know it's not obvious to new observers. So please ask questions. Okay. All right. Well, I'll keep going, and please stop me at any point. So let's see. I think I want to show. I'll show this guy. So at a minimum, oh, hang on. A quick link to somewhere else. All right. At a minimum, our planners are essentially a Python class where we have to define two methods, an init method just to initialize the planner, and then an execute planner, or execute function. The execute function is essentially our entry point from the Caldera operation to the planner and to all of our planning logic. So when an operation starts, what it does is it says, okay, what's the planner associated with this operation? Okay, that's what it is. Run the execute function. And so in this way, the operation is essentially ceding control, or sorry, the Caldera server is ceding control of the operation to the planner. And so the planner will do whatever it wants within this execute function and complete, and then it'll return control back to the server. Essentially at that point, the operation is over. But for the duration of the operation, the planner is in control of the operation. For the operation that we just watched before, we use the atomic planner. The atomic planner is basically a kind of stand-in for just run the adversary as it's enumerated. And so I'll actually go ahead and show that planner because it's simple and you can get the architecture down. But essentially, it's really simply just saying execute planner. This function is a utility function from our planning service, which is a service within Caldera that has a lot of utilities that the planners need. In this case, we're saying execute planner. Execute planner, all it does is looks at what's the next bucket of the planner and run that bucket. And again, like I said before, buckets are equated to functions. So essentially, when we call execute planner, it's going to call this atomic bucket. And then this atomic function here will run until completion. When it's completed, it'll set the next bucket to none, at which point execute planner function knows that, okay, I'm done, and then it'll cede control back to the Caldera server from this planner. Again, this planner is very simple. It's just kind of a step through to the adversary. So all we're going to do for the logic of this planner for the entirety of the operation is cycle through our agents, get available abilities for those agents. Implicitly in this get links function is where all of that precondition logic is. So it'll only get actions that it can do that have met previous requirements and don't have missing requirements, and filter them down and everything. This function right here, get next atomic link, is essentially reinforcing our adversary's our adversaries ordering. It's just saying, again, if I have, you know, 3 abilities that I can run because they have no or have all requirements met, run it in the order that the adversary configure or profile says. So again, really just a simple enforcement of ordering. We'll take that action, which we call a link. We call it a link because we refer to internally as an action chain that's being pushed to the agent. We're just going to append it to the operation. This simple call here takes that ability, or sorry, actually it's a link. There's a little bit of terminology here, but our link is essentially an ability that we take and fill it with all the needed information, and finalize the command so that, like, a link is literally what the agent can take and run the action. So it's just a little bit more built out and configured for the current actual action. But we take that link and we just apply it to the operation. The operation will take that link and put it on the agent's action queue. And then it is just literally piped down to the agent. The agent will run it, get results, and pipe it back to the operation. That post parsing is also done implicitly. So whenever the operation will gets feedback from or information back, or results, excuse me, back from the agent, it'll automatically parse that, automatically fill facts, and all of that information gets added so that the next time we call get links, it has all the new fact information, and so it's very current and accurate. And you know, get links will return new abilities that were not available before because of the missing requirements. Again, after we append or we add another action for the agent to execute, we look to see, we first wait for that action to be executed. Wait for links is literally just a utility function that says pause until this action was actually run by the agent and we got results back. If we have no more actions to do, we just set the state of our planner to none, or next state saying that we're done, we have no more buckets. And then again, the planner will stop and cede control of the operation back to the Caldera server. So this is a really good planner actually for just understanding the basics of how we define really and codify our planners. At the moment, I'll say. I'll pause there, but if not, I'm gonna step back to the planner that we define in the how to build planners and kind of go over that. But I'll pause right here because I know there's a lot of new stuff. Okay, well, I'm gonna assume it's just a lot of new stuff and don't have an exact question yet, but I'll keep going over stuff in detail because I'm sure there's some fuzziness. But okay, so let's go back to the planner we were talking about in the docs here. So I want to go to this planner because it essentially is more complicated than our simple atomic planner. So again, our simple atomic planner is really just a kind of a step through to enforce the ordering that the adversaries have. However, in this planner, I don't want to just strictly follow the adversary. So I'm going to do a lot more stuff. I don't have a full, okay. I was hoping that all the code was in one window, but it's not. So we'll kind of just walk through it here. So for one, I'm going to initialize this planner with a lot more information. I'm going to allow it to actually have stopping conditions. I'm going to create a state machine that mimics this, or at least generally mimics this. This is the state machine field is really a let's say utility that allows you to define a default kind of ordering. But of course, this doesn't make sense because this isn't just a strict one state after the other. So this example isn't perfect, but it's showing if you do have a simple state machine that can be listed in order like this, you can enumerate it as such and use that order to control the planning. but for now, this is a kind of good enough. So it's the general order of the state machine, but it's not completely accurate because you can see there are multiple transitions we can do, and it's not, again, not successive. And then lastly, required is our next bucket. Essentially, we're saying the first bucket of our planner that we want to hit is privilege escalation. Again, we don't have to specify what comes after because we can do that within each bucket, based on its logic, and we can refer to the state machine ordering here if we want, if it makes sense for our use case. Essentially, everything I just said is discussed here in these lines if you want to read later. Some of the variables we pass to our planners are the operation itself and the planning service. These are the two main objects that you need to control the actual Caldera operation. The operation is literally how we control the operation, and the planning service gives us a bunch of utilities to help us with our planning logic. And so we'll go over that a little bit in a second. All right, let's go to our buckets. So like I said, the execute function is what our entry point to the planning is. Most of the time, how we have implemented planners is we might do some init that we can't do in the static init, but then we usually just either call execute planner or we call the immediate next bucket. So in this case, we're going to call execute planner, which again, all it's going to do is look at the planning object and say, what's the next bucket? The next bucket is privilege escalation. All right, so let's execute privilege escalation. You can see this bucket is one of the more complicated or complex logic for all the buckets. Essentially what we're doing is we're grabbing all the abilities that we have that are related to privilege escalation. We're going to get their unique IDs, get the link IDs of those links. Essentially, this is just what do I want to say? Coded, administration. We're not really doing any reasoning here. We're just getting the link IDs, and then we're going to apply those link IDs to the to the operation and wait for them to complete. And then really the only logic we have here is we're testing if those links were successful, specifically in the way that we want to deem them as successful. We do this because some of the abilities for privilege escalation that we'd run technically will complete, but we don't actually have the right privilege escalation that we want. And this can be for a variety of reasons. It could be the output of the ability itself, or what we're checking for success in our default parsers. In this example here, essentially what we're saying is we need to check for a certain fact. So we're checking for a certain fact, and if that fact exists, then we know that we have persistence, we know that we're successful, and based on that, we can move to the bucket of choice, which is persistence. If not, we can move to collection. So that's our kind of our simple logic here, that if priv-esc is successful, go here. If not, go here. In the future, we would like to have a better API for checking facts and their presence and values. For now, this is how we do it. But essentially, yeah, we're doing a Boolean check for if these facts exist, essentially another form of pre-requirements. You could, if you wanted, also create a fact that in itself is a Boolean of a value of a fact. So if you don't want to do this and maybe just check like if your host has root privileges, you could create a fact, that's a parser that runs after we run one of these abilities and then fills or creates that fact, and then that fact becomes available. And the presence of it would be then your indication of what next bucket to take. But again, for now, we use this has fact utility on the operation just to see if the operation has this fact, and if it has that fact, we're good, and we can do our state transition based on that value. Our collection and persistence buckets are pretty simple. This is kind of demonstrating that in many parts of our operation, we might just want to exhaust the abilities that we have. So in this case, we just want to exhaust all the persistence abilities that we have for our target platform and our target, host. And so that's all we're doing is saying exhaust bucket. And this is a utility from the planning service that says, get all the abilities that are persistence tagged, run them all on the operation, and just handle it yourself. I don't need to do any more logic. And then after that, we're setting our next bucket as persistence. Wait a minute. I believe we're passing the current state and the next state. We do this because default next bucket actually also is recording events, and so we pass where we currently are so it can record the state transition just for pure logging and post-analysis purposes. But essentially what we're doing is wait a minute, now I'm confused. Oh, sorry, I misspoke. Default next bucket is just a utility that says go to persistence, or sorry, go to the next bucket after persistence and use my state machine list as my guide. So again, you don't have to use this at all. It was just demonstrating that if you did have a successive kind of state transition, and you didn't want to define it statically, you could define it dynamically and say, I'm at persistence, get whatever the next state machine is. I don't want to worry about whatever it is here. But of course, I could just set the next state, or sorry, the next bucket to whatever I want, as you saw here, and it would work all the same. We have a few more states kind of just showing, doing similar stuff. Our discovery is getting lateral movement links or abilities for doing lateral movement. If we have them, it's saying, okay, we actually have available lateral movement. So we're essentially saying we can do that. So go ahead and move on to lateral movement. If we can't, we're going to go ahead and end the operation because there's nothing left to do. And so we set the next bucket to none. And so via these functions or buckets and how they transition, we have essentially got the manifestation of our state transition diagram that we have here. And so this approach of using buckets and kind of equating functions to buckets has really allowed us to create some planners that do different stuff, as well as flexibility for how we go ahead and define planners and use them. We do have some closed source planners actually by sponsors that are very sophisticated and very specific. So they have taken this paradigm and just run with it. So it's really cool. Unfortunately, I can't share that planner. We do have another planner in the works that is in development right now and testing called a look ahead planner. And so essentially, this is a planner that looks at future rewards based on a reward matrix. And so it's essentially giving a user an ability to either they could specify an adversary, or they could just specify all the abilities that we have in Caldera, and then just give a ranking of those abilities of what it finds, whatever is important, a reward function essentially. And so based on that reward, the planner will run abilities in order to get to the highest reward abilities, and actions. So this gives it kind of a planning look ahead ability, so that, I don't know, say I want to do ability Y, and it's really high reward, but there's 4 abilities I have to run before that to get all the prereqs. And so that's what this planner will do, is it'll allows you to run operations not with a specific adversary in mind, but just with a specific kind of reward matrix for different abilities and what their overall value is. And so it'll try to execute those abilities first before others, and then it'll chain together all the prereqs required, or the abilities and prereqs required before that to go ahead and run. So you can see this one's a little bit more advanced, got a little bit more advanced logic. It is currently, we are testing it, and so we are hoping to have it merged in within the next 2 weeks. However, it is on a PR here if you want to look at this more advanced planner. It is one we are excited about, and it's actually fun to test. And you know, we get different dynamic behavior than just, you know, running the adversaries in the vanilla form that I showed. But yeah, I think that is the gist of it. I did mention we have planning service utilities. Again, these are built-in utilities that just help when writing planners, just for common tasks. So, you know, if I ran a bunch of tasks or actions to an operation, but I want to get the cleanup links now and run those, you know, I have a function to do that. I can check stopping conditions, etc. So again, just all these extra utilities for logic that, you know, is common, and we wouldn't want the user to rewrite in all these on all their planners. And then same thing with the operation utilities, where we, you know, directly access and control the operation. We do have a knowledge service that is in development. I'll say it's very alpha. And so we are trying to switch more over to a knowledge service approach instead of just a planning service, to handle and manipulate all of the information we have. We do have these utilities available right now. We don't use them in any public planners yet. It is currently a very active spot of development that we're doing, kind of closed source right now, but we're really hoping to add to it. Unfortunately, I think I'm out of time because I do want to get on to some of the deception plugin work that we've been doing. However, all of that information is available here on the Read the Docs. So I definitely encourage you, if you're interested, to read through this. Not only read through this and look at it, but also ping us on the Slack channel or email us. This is of great interest to us, so we love to discuss and talk more about it. We also have had actually 2 or 3, I'd say, students as well as professors write their own planners, and so it's always super fun when they email us very esoteric, specific planning questions when they're trying to do, and then some of them are doing really cool stuff. And we had a few theses actually were Caldera planners by students, and they did some really neat things. However, I planned poorly, and so I'm a little over time. I know Dean is on, and we do want to get to showing off some of the deception stuff. So I'll pause one last time for any questions about the planners that I went over, or Caldera planners. And I know it was a lot, but hopefully everyone can refer to all these resources that I've been showing. Yes, Andy, we finally the look ahead planner. Yes, coming into the public spotlight. Cool. Okay, so I don't think I have anything else. Ron, is there anything else that I missed before we toss it over to Dean to show the really cool deception work that we were doing, and really was the impetus for our submissions to ICAPS this year?
I don't think so. So you covered the core here of the planning interface, and so this is if you're going to take your PDDL planner or RDDL planner or whatever and try to hook it into a cyber operation. This is the interface that you'd be working through. So just wanted to emphasize that point. But yeah, this is great.
Cool, awesome. Oh, I hope everyone else liked the planning part. I didn't bore them, but it's super cool to us. So, and this is definitely an active area that we're working on. So, really hoping to have more work and documentation out on this front. But with that, I'll go ahead and stop sharing. And I think I saw Dean online if Dean wants to switch over.
Give me 1 second.
Sure, no worries. All right, I'm gonna sign off and just be on chat. But thanks everyone.
which screen is the share showing? Is it showing Caldera?
Yeah.
Okay. It's popping up on the wrong monitor. So as long as you guys can see the Caldera stuff, that's fine. So yeah, I'm going to walk through just kind of two plugins that aren't currently publicly available, but that we used to kind of run our experiments that the bulk of our submission to ICAPS. So this is one of them. This is called Range. It's for provisioning a kind of cyber range in the cloud. So it allows you to kind of spin up infrastructure and provision it in various different ways in order to kind of create real test environments that are, real hardware running in the cloud that you can run Caldera on, and kind of, plant them with information that's interesting to test with, and kind of set up software on them that kind of makes them more realistic. So I actually went through the privilege of setting one up beforehand because it takes a little while, but I'm going to just walk through the UI for reference. So to kind of start it up, you really just start by specifying, which operating system you want your VMs in the cloud to use. In this case, probably just we use Windows, and then you really just specify how many of them you want. So we just say, we want 3 on our range to test with. You can add users. It defaults to just setting up a single administrator user, but you can add additional users if you want to do that. And then you can set up which Caldera agents you want to be spun up on each of the hosts in the range. So you can start and just say, I want to set up, instantiate a red agent on the Windows hosts, and it'll do that to start up. And then range also comes with this given kind of selection of various features. And these are kind of additional automation tasks that kind of can seed information or install programs or set up additional things to kind of give a little bit more life. Since if you just set it up raw, then it's really just empty hosts running on a network. So the one that we primarily used in our experiments is called Credential Seed Ring, and it basically plants. It basically adds a user to each host and then kind of plants the username and the password for that user on an adjacent host in the file system, kind of in a ring formation, so that if you have an adversary kind of attempting to do lateral movement in a network, the information necessary for it to do that is kind of laid out in a ring, so that it can go from one to the next, but always kind of in a linear order. So that's the one that we kind of used for our experiments. And if you click that, when you go down to create domain, Range will handle the creation of all those users and the planting of all those credentials for the testing purposes. So it really makes setting up that environment super easy to do for an experiment. So after we've got that set up, which I currently have one set up that I spun up in preparation, I set it up with a single domain controller instance, which just manages the domain, and then 3 workstations. Each of those workstations was configured with just that ring topology. So there's each one has a user, and then each one also has credentials for one of the others, so that an adversary will be able to propagate. Once we have that, we then have the option of using this other plugin that we've written for our research purposes that allows us to plant kind of deceptive artifacts on that range. So while the range kind of has 3 legitimate hosts, one of the potential deceptive artifacts we can plant is fake hosts. So to all outward observers, it would appear as if there are more than 3, even though there are only actual 3 computers in existence. So that's what we're going to take the opportunity to do here. Is say, if for the sake of an experiment, we might say we want to decide, we're going to plant 4 fake computers on the network, and by just basically pressing the Add Selected Deception button, there's not great feedback in the UI, but it'll kick off an Ansible script in the background that is going to go then and plant these these fake hosts on the domain controller for the network in AWS. So in the background now, it's kind of doing that work, and it'll be ready for us in a second to work with. So in preparation for that, we can go over to the operations page, which Michael walked through previously, and we can kick off an operation to see kind of how that works. So we'll get to use a little bit more of a complex one than Michael was able to, since we have actual hardware and we have an actual network to work with. So give it a name, and I'm actually going to use a special planner that we have written up. So I'm going to select the Alice 2.0 adversary, use a default fact source, and the planner I'm going to use is this one called deception aware buckets. I don't remember if Michael touched on the buckets one in particular, or sorry. Oh, actually, I'll probably use this deception aware atomic one. Probably be better to use. So the atomic one was the one that just walks through kind of in the atomic ordering of the adversary. The deception aware atomic kind of adds a little bit of additional logic that allows it to kind of discount knowledge that is not useful to it. So the default kind of atomic planner just runs the facts and kind of kind of takes into account any knowledge it uses, but it doesn't really consider whether that knowledge was useful to it. So the deception aware atomic takes in a little bit more information and takes a look at whether a particular action actually succeeded or failed. And in the case where it fails, it's able to go back through and discount knowledge that it used and that it failed on. So I'll show an example as this runs that shows kind of how that matters. But if we kick that off now, we should be able to see it start running. So yeah, while I let it do its thing, because that'll probably take a little bit, I can go over to some operations that I had run previously. I ran these last night in preparation. But basically, this is some of the knowledge at the end state of an operation being run on a cyber range. So this is an example of like running it against this range that has no deception on it. So you can see in general, there are these remote.host.fqdn facts with these values, and these are the facts that basically store the domain names that are found when the adversary goes to look for the hosts on the domain. So as you can see, it kind of finds 4 of them, the domain controller, and then the 3 legitimate hosts. And you can see that its scores are kind of positive integers because the scores get incremented each time that the fact is used. So they've all been used numerous times for pings and other things that Alice does. So they all have kind of positive values. And if we go down here, this something else that I think Ron had been asking about was other kinds of relationships and facts as a good example. It could be certain things can be found, such as like a username fact that was found is in the triple, like has password, and it connects it to a password fact that was found. So that's how it connects kind of that a specific username piece of knowledge is connected to a specific password piece of knowledge. And it's also useful to show which hosts are accessible from which other ones based on credentials or network topology. And there's various other things that this thing finds while working through that. So now if we go over and look at the same thing, but with deception applied, we basically see that there's way more domain names discovered by the adversary. So it has those same kind of 4 original ones. It has the the domain controller and the 3 legitimate hosts, but it also has these 4, and these are the 4 deceptive ones. And you can see that the planner didn't really consider the fact that they're not real, other than that they I'll show you in a second that they don't work. But it kind of they all have positive scores, meaning that they were at least used multiple times in the operation. So if we go back over to operations while that thing runs, we can take a look at kind of the steps that it went through. So without the deception, you can kind of see it kind of runs pretty smoothly throughout the entire thing. It kind of starts off by doing the discover hosts. And this is where it finds those initial pieces of information. And then it goes through and kind of pings them to make sure that they're legitimate. And that's kind of where a lot of the incrementing comes from. So these, in general, we'll see in a second, the pings are where it fails once they're fake. But since these ones are all real, the pings have no issues. So this operation really gets through completely successfully and propagates. And these ones that fail at the end are kind of cleanup operations. That, you know, if the things have already been cleaned up, they fail anyway. So that doesn't really have much to do with the deception. So now if we go over to one with deception, and we scroll down a little bit, you can see that in the same kind of batch of pings, there's now this collection of them that all failed. And obviously the reason that they failed is because the hosts don't actually exist. There's no actual computer for them to connect to, even though it thinks it has that piece of information. So we can see back at the discover local hosts. This is where it finds that original, whole set. And you can see that the kind of fake ones are all included in there. So then it goes and tries to use them in the pings, and obviously, it isn't really gonna work for that. So I think the conclusion of the test, and since it goes through this and uses them multiple times, it's not really considering, that these might be fake, and that maybe I should stop using them. And kind of the effect, I think the text is a little bit hard to see, but it can be seen that, like, when there's no deception, planting deception on the cyber range, we've kind of had an impact on how many actions the planner in the operation has to go through, as well as probably kind of how long it takes and how much effort it has to exert in order to get to its final goal. So I don't know exactly how. I think hopefully at least we get to some sort of end state. The atomic planner is kind of slow, so it might take a little bit to get to a point where it's getting decent results, and hopefully we can at least see a single pivot by the time we're watching this. In the meantime, were there any? I know that I probably threw out a lot of information. I think I have a tendency to talk a little fast. Were there any questions relating to anything?
I have one. So is there any way to forget information from the database? So detect this information, this host is not real, I should remove it from the database?
Absolutely, yeah. So that's one of the kind of the point of some of the extra logic that's worked into this planner that's running right now. Is it basically, the original version of it basically runs the thing and then just kind of moves on to the next step. The extra logic added into this planner basically says we run the operation, or we run the kind of ability, and then we look at the result of it, right? So if it failed, then we can use the knowledge store stuff that Michael had kind of talked about towards the end, kind of look up that piece of information that it used, and then depending on the severity of it. So in the case of a ping, for instance, I think there are various reasons that a ping could fail, right? It's not necessarily that a host is fake. A ping's kind of not the most severe of a failure, right? It's possible that there's some other temporary network issue that's stopping it from being able to ping at this moment in time, but you still might want to consider that in the future. So this planner, for instance, rather than deleting the fact outright. It just decrements the score. So it makes it less likely to be used in the future, but still still allows it to kind of be in consideration in the future. Another case though, I'm not showing it in this demo, but another type of fake deception we have is the ability to plant like fake user credentials. So if we plant 50 fake users, and it has to go through and try each of these users for each host. The first time you try a password and it doesn't work, you can make a pretty safe assumption that that password does not work in general. So the planner is kind of designed so that if it comes across a login attempt that fails, you can go ahead and delete that bit of information because that credentials is pretty safely assumed to be not useful at all. So yeah, the planner does take into account some of that information. So we can probably
the score, does it represent how much you trust the information or how much you are certain that the information is actually correct, or is it just an indication of how often to use it, how often to try it, or is that the same thing?
I think it could be used as a representation of how much you trust it. I think the way Caldera calculates it is that it's incremented each time. So I don't know, it's incremented each time it's used. So if the first time it's discovered, it'll be defaulted to 1, and then each time an ability uses it, it increments the score. So that's where you kind of see the scores for these ones. Kind of, they're all differing values just based on how frequently they're used. The reason probably this one is used last is because it's the last one to be propagated. This one has the highest score because it was the last one to be propagated to by the adversary. So it was kind of pinged repeatedly before it was actually reached.
Okay, so I think I'm missing one part. Is the score high because it is used often, or is it used often because the score is high?
I see what you mean. In this case, it is, in the case of this planner, it is high because it is used often. I don't think the current batch planner that I used to run this considers the score. The score is a thing you can use to consider whether to run a fact. So, for instance, it's easy enough to kind of when Caldera kind of generates all the options of the next things it can do. It's easy when you write your own planner code to kind of sort that by score and say, I only want to run the ones with the highest score, or something along those lines, that you can take that into account. In this case, when we're not considering that logic, then I would say that the score is high because it's used frequently.
So Dean, is the score, is the computation for score something you can change within the planner itself, or would you need to change a different part of Caldera to modify the score?
So the default behavior of it being incremented, I think, is built into Caldera. If you make use of the knowledge store kind of components, which I can show in I don't know how easy, I'll zoom in a little bit. I'm not sure how easily this code will be legible. But this is the wrong thing. So if you make use of the knowledge, so here's kind of an example of how to use the knowledge service or knowledge store, and it kind of has this update fact method that you can say, I want to update the fact with this trait and this value, and I want to set its score to some other value, and in this case it decrements it, or you can use the knowledge service to delete the fact altogether. So through using this knowledge service, you can modify the score directly yourself within the planners.
Okay.
The default behavior is to increment, but you can absolutely code in your own behavior based on just updating the score yourself.
And if you don't mind me asking, for delete fact, have you guys done like extensive testing to validate what happens when you remove knowledge from the knowledge base? Because I know that can get kind of wonky sometimes when you forget stuff.
That would probably be a good question for Michael. I know Michael's done a bit more of the knowledge service design work lately.
I wouldn't say extensive testing. A lot of, I think we will get that with some of the experimentation we want to do this year. We're planning to do kind of end of summer, fall for the Mirage plugin, where we have more complicated topologies as well as deceptions and planners that we're going to be using.
Okay. Yeah, I was just curious about it. As a, traditionally, planning in Caldera has been strictly monotonic. So you start removing stuff, who knows what happens?
Yeah, and part of it, as you know, Andy, is some of the architectural and structural API interfaces that we have now within Caldera, and easily manipulating the knowledge and searching for it and querying it. And so that's also a big action item this year, is to make the knowledge service much more in use and almost, well, I don't know if it would fully replace the planning service, but just being available as a very serious utility for managing all of the knowledge.
Mm-hmm. Cool. Thank you. Yeah.
Not sure whether we'll get to a pivot or not, but at least it got through the first batch of failed pings. I don't remember if the knowledge store will have updated with that information by now. Don't think it will have.
Oh, Andy's
yeah, the fact
asked in chat if you could just update the ping frequency to get it to complete faster.
The beacon frequency, if you go to agents.
Beacon frequency.
Yep.
I don't know if that'll update. I feel like that'll update live. Yeah, the sleep timer.
Yeah. I've not messed with this that totally. Can you just like set it to like 0? Is
Like
that going to break it?
1?
Mess with anything?
I do like 2 and 4 maybe, or 1 and 3.
Okay.
Just because I don't know if others have done this too much.
1 and 2, yeah.
But I know that sleep, it used to be different between when the agent was just kind of doing nothing and when the agent was alive in an operation.
Yeah, we'll see if.
And it might take a minute or 2 for it to beacon home and
Yeah.
update the frequency. If you don't mind me asking, it's not technical, but I guess this is for Ron and Michael too. Like, are you guys planning on open sourcing Mirage or even Range, or is that just on hold?
I'll
Yes.
I think I know the plan, but I'll let Michael answer that.
Yeah, so there is, we would love to open source Mirage, especially after all the stuff that we're going to be adding to it over the summer. The biggest dependency is range. So it's Mirage is, completely tied to range. And so it's really useless without range. And so the bigger requirements are getting range out, which there is support for. It's just a matter of O&M because range is a much bigger plugin with the user base, and as you know, Andy, range has significant development and O&M implications. So, and it's not fully the stakeholders and ownership of range is wider. So it's all this to say it's taking long. It will take a longer time. I know Ron and I were trying to get it open source by now, but it just wasn't doable. And so I don't want to give a target timeline because I've been proven wrong before. But there is a general push to get it open source. There's just good reasons why it hasn't been yet.
So I know MITRE, I'd seen them offer something at times called a like research use license. I don't know, I don't want to generate work for you, but I don't know if that might be an option if there were researchers who were interested in using the code to get such a license. You know, non-commercial use, no cost, but to, you know, the idea being to do research and send you feedback or something. So if you guys wanted to push that, that might be a way to at least get others to look at some of the code, because this is super interesting. And it's nice to see the progress from, I think last I saw some of this, it was all like terminal stuff. And now it's, you know, much more robust. So I don't know, just throwing that out there as something that might be worth looking into.
It's a good idea. We can definitely look into it. I think Range might have some research licenses, but yeah, we can definitely look into that.
Yeah, I think at this point we've seen the first pivot. So if we go back to agents, we originally had one agent. Now we have two running on two different hosts. Yeah, we won't be able to see the state of the knowledge until it's over, but I don't know if it's we're sticking around to see that follow through. Yeah, I think that's probably about all I had. For the sake of my demo, if there are any other questions.
So does the deception aware planner just decrement the score when it uses a fact and the fact doesn't lead to a good outcome?
In the case of a host name, yes. It kind of, I think we want to make it a little bit more general, longer term. Kind of right now, a little hard codey. So in this case, it's basically like, you know, when it sees a failed action that failed due to the host fact being kind of included, or failed and had the host fact included in it, in that case, it'll decrement. If it sees a failed action that, you know, had failed and had the password included in it, in that case, it'll remove altogether. And that's kind of in the simple handler way. I think I'm kind of in favor of a more general solution that kind of just, you know, incorporates that into a general kind of decrement. But in some ways, yeah, just in general, it in the case of host names, it decrements.
Yeah, no. This is super cool to see the handler as not like an expert system, but just a rules-based approach where you can have different options for how to deal with a fact not working. Because yeah, if a ping doesn't work, that's different than like a password doesn't work.
Right.
So do you think the ping or the beacon frequency didn't take hold, or?
I think it seems faster. I think
Okay.
I think it's about to pivot a second time. So I think it's just these ones might just be slow in general. The ones to start the agent, because it definitely seemed like some of these other ones were going much faster.
Oh yeah, some of those went by fast. Okay.
When a new agent gets spawned up, it takes a little while. Part of it being like the new agent defaults to using the slower callback until, I don't know if it's like the first response it gets from the C2 server or the second or third, that it's like, oh, I should beacon every 1 or 2 seconds.
Let's just double check that they're all on. They might be. They might.
Oh, the new ones. The new
Yeah,
ones popped up with a. Okay. So where is that setting? To control the default.
Actually, Michael, I don't know. Where's the default?
Repeat your question.
Is there a way
Oh,
to set like a default for these?
Yep, go to configuration, the red. No. Still on the tile, agent tile. Yeah.
Gotcha.
So Florian, you were asking before about the number of agents that the red agent runs, and you saw we started with 1 agent, and now we're up to what, 4 or 5 in this operation.
Yeah, and it's generally we've got 1 on each hostess. They both started 1 on this one.
Yeah, I was wondering, like you mentioned PDDL planners before, like plugging in the PDDL planner in this framework. How would you deal with this there? I mean, this is an open world problem, right? There's new facts being created and new agents being spawned. How do you deal with this? Or how would you deal with this there?
Yeah, so that's a great question, and yeah, there are some questions that need to be answered there about how to do it. Some things don't need. One is some things don't need the open world assumption. We have on hosts we have a we can kind of put in, we know that there's a user, we know that there's, we can structure the domain in certain ways to deal with that. I have ideas for how to handle, for how to handle the open world assumption for specifically for the case where it's a monotonic domain, and a couple more restrictions on how much, how many, what types of things can be created in the structure of the actions. I think we can get it down to where it's, where we can encode it in the PDL domain. But those aren't, obviously those aren't, fully formed, or I'd have a submission to ICAPS with it. But it's definitely something I want to work on, and I'm interested to see other people work on it too, because it's a very, it's a very important domain for people to use, and it'd be unfortunate if we limited ourselves at ICAPS to say, oh well, it's an open world, let's just not consider that, consider that problem, right?
Yeah, definitely. Yeah, it's an interesting problem. Would be cool to see like more work in this direction, like how to deal with this open world issue there.
Yeah, and that's the reason why we proposed this tutorial and the demonstration in the first place, is because we're trying to say, hey, look, this is not just an important domain in the abstract. We've got, if we've got a framework where you can actually go and implement your ideas and run them on real hardware, and get people behind it to use it in the real world. Hopefully on the defensive testing side. But yeah, and that's what we're hoping to see happen.
So there is already the IPC domain, right? How does that relate to this?
That's that is and he's the one who did the encoding of that. But that's compared to this. The IPC domain is a specific adversary, where the logic has been, the logic and the specific network have been encoded in PDL. So compared to that, the planning problem is like it looks more like hindsight optimization. So what are the an optimal path in the Caldera planning PDDL domain would be as if you knew exactly which actions to take to discover the right host, to discover the right password, to apply the password to get to your goal. And so that was serialized from a much older. Andy, do you remember which version of Caldera that was serialized from?
Yeah, that was nominally called Caldera version 1.0, and everything was very different about it, but that version of Caldera had an explicit customly written logic to some extent for preconditions and postconditions, much more explicit than this version. And we had created a converter that changed it, or that was able to spit out PDDL from that custom logic. But Florian, to your original question about like, well, what do you do about new objects? And that was of course the biggest problem with doing that conversion back then. That's why we had the custom logic. And what we did in the PDDL was, well, we're just going to make all the objects that we care about in the environment. So there's 10 hosts. We're going to make 10 hosts in the domains or in the problem specification for the file. And then during planning, we're going to explicitly track like whether or not the adversary knows that an object exists, or even if an object exists. So not a phenomenal approach, but it got the job done. And it's maybe also worth saying that this Alice adversary that Dean is using is indeed the same profile that we were using, 4 or 5 years ago, that formed the basis of the PDDL. So the semantics are a little different, but it's still the same, core idea.
So did I get this right? Like the IPC domain is like assuming that like you're basically analyzing this after the run, so you know the facts already. So this is why it can be encoded in PDDL. So this is like making a closed world in this sense.
Yeah, that's a good view of it.
I see. Thanks.
Ron, was there a plan or any actions to try to release the ransomware domain?
No, but I should.
Okay.
I should do that. Because that's the one that's not monotonic and won't work with my techniques. So I should make sure it gets out there so people don't think the work's done if I ever get when I ever get mine out.
Yeah, and I know that there's been some papers that have looked at the Caldera PDDL domain, and my memory is super hazy, but Florian, I don't know if you've previously worked with that or taken a look at it.
Okay. I think we're gonna stop the recording now, and feel free to keep chatting, I guess.